Right folks, it's Saturday and this came today, so I may as well get on with it. Looks like there's quite a lot wants doing. Customer has used us before, he's an end user, and it's Fidelity 2001, so it's Cybernet 002F chassis. He's bought it off eBay. Unfortunately it comes with a power mic, inverted commas, and these power mics were cheaper than standard mics, so that rubbish. Doesn't have a power lead. See what we can do about the connector. I hate to add things onto his build, but it'd be nice if we can. We've got connectors in stock, but it's a matter of which type it is, and a broken inline fuse holder, so it does want sorting. But for now, we'll see if the set's actually working. I'm not going to power it up willy-nilly because it's an unknown. So he's had it sent straight from the vendor to me, cutting out one of the postage legs, which is a sensible thing to do. We've also had from somebody else another two sets, a Maxcom 30E and a Rotel RVC 230. So the Kerner Beta 1100 has gone down the queue because that's one for us. Okay, so it's not plugged in. You know what? I'm going to unplug this stupid mic. That's just an unknown we can do without. We can play with that at the end, but I won't actually be doing anything with it. So, just looking for burnt out. At least it's got the correct ballast resistor. We may have to change that because these are only 3 watt rated. So if the radio doesn't do 3.5 watts, I want it to do more than 3.5 watts. We may have to change that to we have 6 watt ones, which will then pass the right kind of current. Just want to check that the protection diode's in place, which it is. Now I can't see anything blown up on that, but we'll put the bottom lid on just as a thingy for the possibility of capacitive effect. Connect that to my crocodile clips. Start connecting it up. So with our standard replacement mic, wherever I put that, we did the Dave Lee Travis cassette tape yesterday. The software I've used is this. I dare even say it's this Clip Chimp or something. Because I need to replace the audio track. My normal software doesn't do that, and I think it's one of these softwares that sends it all to some server somewhere via a cloud, then processes it in America, and then it comes back. Well, it's been 24 hours. I'm sure I could have found something else to do it. I've actually got some software which came with some Twain driver, so I should have tried that. But no, I thought, well, that's the replacement for whatever. I do have a Windows Vista computer, I do have a Windows 98 computer, and I do have a Windows 95 computer, which none of these computers are online, so none of their software gets updated, in inverted commas, because the updates are usually a downgrade. And you know, I can always fall back on those, but it's annoying when I'm trying to get videos out and then it does that. So where are we? Let's put the power supply on. We'll tread carefully at 9 volts, current limited to 100 milliamps, and the radio's powered up, so that's fine. Go to 13.8 volts. That was 12. We'll try 13.8 again, and we're lit up. It's bit of a stiff channel selector, but that will ease up no doubt with use. Meter lamps out, which is frustrating. We'll have tone to high. Right, we'll plug in the public address speaker. And we'll plug in the test gear into the extension speaker sockets. I also want to look at a camcorder, which is quite a modern one by my standards, which is throwing up some error code. So I may as well, since I'm going to do it anyway, I may as well do it on here. I think I've only one church service tomorrow, so we might do that. It'll be something stupid like dirty edge connectors. Okay. Testing 1 2, testing 1 2, 1 2 1 2 1 2. Got dirty volume control. We've got dirty mic gain. Let's have a look. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Which is mic gain? 1 2 1 2 1 2 1 2 1 2. Mic gain doesn't work. That means somebody's linked it out. So, PA, sockets work, meter lamp doesn't work. So, volume control, dirty. Mic gain inoperative. That's why it's useful to have PA which works. Well, I can't see just like that, but we'll come back to that. Let's get the rest of the set working. Right, we're back into get back into CB mode, and the first thing we'll do is the VCO. And without digging the manual out, can I remember enough of it to get by? So we'll just see, because I can never remember whether these are a floating chassis. It is. Yeah, it's the 134. This isn't. So this is a ground. 134 is floating. I've only been doing them 40 years. But I've always had a memory like a sieve. Right, far side of capacitor, whatever it is. We want to be on channel 1. It's something like 2 volts. No, -6 isn't acceptable. So just that one for... I might have to look this up. We have got transmit. If I put picture in picture on, you'd see it. Let's just see whether we can get a positive voltage instead of a minus voltage. We can. So now we're out of lock on receive. Back to transmit, now 2.7. Receive 2, transmit 2, that'll do. I'll come back to that just in case I'm not quite right. I'll look at it on the computer. Right, so if I go to channel 40, we've got 3.5 and we've got 2.8. So to me that's fine. But we shouldn't have had a minus voltage to begin with, so that was wrong. But I will just verify with the service manual because I just have forgotten. Right, transmit. Let's put picture in picture on. Okay, we've no longer got transmit. So we're going to waggle the VCO until we get transmit. We'll come back to that and do it properly again with the service manual. Let's get this tuned up. 2779073 is the frequency. I'm going to just write that down. I haven't shown it you yet. 2779073. That's not scarily out, but I'd like to pull it up if I can. Now these sets are 40 years old, some of them aren't quite coming up as much as would be ideal, but saving the cost of replacing the crystal, if we can get a bit higher than that, that's absolutely fine. You'd have to be a lot lower than that for it to be out of spec. Right, so right now we've got 2.7 watts on channel 20. Let's look at the other channels. Channel 40, we've got 2.7 watts. And channel 1, we've got 2.6 watts. Actually, it's usually the other way around. Low power for what it's worth. Let's go to channel 20. We have got 155 millivolts. Milliwatts. And the transmit current for full power is 1.17. There's a lot of current consumption for 2.7 watts, so something's not right. Okay, so making sure we're on channel 20, we'll start tuning the thing up. And hope they're not all broken. We're now at 2.8. The good news, this just hasn't been messed with. Well, not in this department anyway. That was in the optimum position. We've gone beyond the 3 watts now. Make sure the placement of some of these is spot on, because it can affect the transmit power quite dramatically. That's alright. That's alright. That's alright. That's alright. It's doing 3.3 watts. We need to change the ballast resistor. So it's been all these years not doing anything like 4 watts. Right, we have a bag up here. we're gonna drop it to from 3.3 to 3 ohms, and go up this. Although it's even smaller, this is a 6-watt resistor, whereas the one which is factory fitted is a 3-watt resistor. So turn the power supply off. We'll recover the sister flex sleeving off those. We've got that new, but you may as well recover it. To be honest, that doesn't look as clean as it ought to be. Which is how you get future dry joints. We're having to order these a year in advance. Tell you what we can do, unplug the BA. Sometimes you've got some poorly looking capacitors, but not on this one. Potential dry joints. Keeping it away from that capacitor. Right, we'll power it back up. 13.8 volts. And let's see what we've got now. 4 watts. .37. Full watts. Let's look at the other channels. I like it to be within 0.1, but you know, it isn't. 3.8. And channel 1. .05. I'm not going to delve further into that. So the meter is banging across. So it was FSD, full scale deflection, is now 4. Low power. It's not adjustable on these, so you get what you're given. It's now 260 milliwatts, which is a bit near the 400 it's supposed to be. It was we'll put -1 plus 1. We'll come back to that. Now, as you know, the deviation meter on my Marconi test set is unreliable, so we'll use the test set behind. Just going to get an initial idea off the Marconi test set. Wallow. Interesting, it says we don't have any deviation. Wallow, because the mic gain works. So the mic gain control does nothing when you're in PA mode. How interesting. That's one fault which hasn't... 1, 2. It says it's about 1.8. I won't write that down. We'll just look at the test set behind me. I keep saying I've got 6 test sets in total. 3 Marconi ones like this one, and various others, including the quartz lock one behind me. Our primary thing here is business radio. This is the only bench we do CBs on, although we have done the odd CB on the odd other bench, and there is still in the back catalogue. So the bench behind me with the quartz lock 272, we can't use that for CB for receive because it starts at 88 megs. But on transmit it works down to 10 megs. Changes glasses because it's a different meter. Wallow. Wallow. That's bizarre. It's right over the top. Wallow. It's greater than 5. Right, we'll go back to Marconi. See what the Marconi now says. I'd actually got it in the wrong setting on the Marconi. I got it on 25, so it looked to be 1.6, 1.7, so in actual fact, because it was in 25, it was actually showing 10 on the Marconi test set. So now we've got it right, and we've set the Marconi into the correct mode. Wallow. It's showing a bit under, which is not right. So it was greater than 10. I'll put down 10. Ridiculous. So it's now 2.2 with a peak of 2.5 kilohertz as it should be. Right, let's do the frequency. Not sure why all these wires are untied, you know. Right, we're placing any bets as to whether it's going to go. I'll tell you what, it has. And there's still a bit of adjustment. Wow, go to the foot of our stairs, but except we haven't got any. Right, so we'll look at the receive. I'll try and get that done, and then I need to go and do something else. Where are we? We'll go over to receive, and I'll just set the signal generator. We can set that spot on because we are spot on. Sounds a bit strangled and horrible, but there you go. Let's go over to the sine nav meter and then we can write down what it's doing. So it's doing 0.98. That's capable of better than that. 0.89. For 20, if it'll do it, it will do it. Actually, it's not that bad, it's 1.8. Squelch, while we're doing all this, so full squelch never opens. So the transmitter seems to have been left alone, but the receiver and the presets are all mashed up. And squelch, let's go with the attenuator so you can see what I'm doing. I've got this now set to 0.3 of a microvolt. That's threshold on the radio set, signal generator back on. .88. That's actually no, it's point. No, I'm in that scale. No, it's 0.88, not 0.88. So considering the squelch is one of the lousier bits of these sets, that works all right. And the S meter, I put 100 microvolts on the signal generator, and if we can see it, that it's actually 7 and a bit. So what do we need to give it to make it do 9? And that is 165 microvolts. It's not miles out. Right, so we will go over to the oscilloscope and put 100 microvolts on the signal generator, enough volume to give myself a trace, and we'll get the detector adjusted. Which sounded out, and it was out. So now we're going over to the cyanide meter, 4 dBs. So we're not saturating the receiver, and we'll start with the first. No difference. No difference. Go with these IF ones. No difference. No difference. The signal one for this one. We'll just go through these IFs again with a bigger signal. Well, it's not that good. Let's go through these again. Right, so our new figure is 0.9. .83 and 1.45 microvolts. Oh. Okay, so the RF gain wasn't at full. So now these figures are disingenuous, aren't they? Okay. .28 microvolts. .23 and 0.57, turning it into a lovely receiver. So we can retest the squelch because I've not altered that. It's still never coming in, so that hasn't changed. So with the signal generator at 100 microvolts, let's see if we can get the squelch to come in. I could have sworn on a stack of Bibles I'd turned the RF gain to full. Must be my fat tummy that knocked it. That's now 100 microvolts. If it opens at the bottom end, it does. Sometimes when you disconnect the aerial on this chassis, you don't get the squelch noise, but on this one it's alright. On those fake Amstrads, as opposed to the real Amstrads, you can sometimes get that. But these are always genuine. Right, so what have we got at the sensitive end? I've set threshold. It's now 0.77. So that's going to work nicely around Scratchy Corner. Good. So the S meter, let's go put S9 back on the... It's now banging across, but of course I've now got the RF gain in the right place. So it's now 9. So that's now correct. So we've already checked the switches, they're alright. So I just really need to clean the volume control. So I have to get a Service-All cleaner from Mr. Chippy because I've got one here but I haven't got an applicator. I need the applicator. Don't know where all the applicators go. I think there's a planet somewhere along with television remote controls. I say that I don't have a television, but you know what I mean. What am I doing? Oh, we're going to just test this mic. Maybe there's a battery in it. Just imagine what this set sounded like with a power mic and being set to greater than 10 kilohertz deviation. He must have been transmitting on 5 channels at once. But it's actually sounding lousy, except to everybody other than those people with the Fidelity 1000. Oh, you sound lovely on my Fidelity 1000. I can hear you on all 40 channels. I'm not messing with that, it's just waste of time. So, right. haven't got any batteries on here, so there we go. So I'll come back to this, and I need to look at the service manual for the VCO, and we need to clean the volume control. So really, we've got a very good receive. We've got a full 4-watt transmit. Let's see what we can do about that. We've got those connectors in stock, if it's that type, which I think it is. Right, moving forwards with this a little bit. I've taken off the old wire. What I was going to do, you got that nasty join in it with the crimps, and it'd be a bit of a bodge to leave that in, so I thought we'd cut that out and use the further down bit of wire. But when I came to try and strip it back, I don't know whether you can see, I put it against that white paper, it's actually black because it's been full of water. So I put 2 brand new wires in, and we have these connectors. We got them on eBay for people who want to use them. They're not cheap, and what's even worse is the post keeps going up, doesn't it? So it's this square round one on these, and these are put in from this side. So you've got a notch, so it goes in from the back. First of all, we're going to put the wires in. So it's positive to the bottom. So they've clipped in as they should do. If we look at the picture of a power lead, we've got red to the square one, and we've got red to the square one. We do those power leads as well. And this customer is going to be under no obligation to buy a power lead from us. You'll notice I've put the ferrite beads back. And these are the original proper ones, which are still manufactured, but take about 6 months to arrive. There we go. So we're back to having a proper power connector on the back. The only thing I didn't bring was a service hole. Let's see if we can sort this VCO out. This now makes my job harder because I'll just have to poke these into the back, so we don't have these on the bench. They're for selling, not for using. Right, 13.8 volts, on we go. I'll connect to the test gear again, or we'll end up transmitting with no load, won't we? Back to our mic. Might as well take picture in picture off. Switch radio on. I'm looking for a meter lamp lighting up. I've forgotten about that, it's got to be done. We'll, instead of connecting to the test gear speaker, we'll use the one on the wall. Is it that one? Yes, it is. That's one job done. Let's look at this VCO. So just in case I'm wrong about the polarity of the chassis, I'll connect it to one of the cans. Because I wasn't wrong about the voltage, it should be 2 volts on channel 1. Ah, he says it's on channel 1, yeah. 2 volts, channel 1. Yep. So I'll just pop the radio back down to channel 1. Just like that. Far side of capacitor 9. They want you to do receive first. So we'll just pop this up to, I've got it on the very coil I'm wanting to adjust. And it was affecting the reading, which was actually spot on. Right, in transmit. Wants to be 2 volts. receive, transmit. Now we check it with channel 40. I've got 3.5 volts and they expect it to be in the 4 to 5 range. Well, that's in lock and it is on both transmit and receive. You've got to take this with a pinch of salt, but that lower figure is important. So that's now set. That's 2 tasks done. Now how do we get to the... I'll turn the power off. How do we get to this meter? No doubt we'd take everything off again. Can we get to the meter without taking it out? No, of course we can't. You know, normally, with us being a trade supplier, not a retail supplier, I'd leave meter lamps for the supplying dealer. It takes up a lot of time when I could be aligning sets which not everybody can do. Didn't say I could get that knob off though, did I? Notice the 2 things were broken on the other side. And there isn't much wire. I don't really want to disconnect the mic socket, but we might be able to cope. That's there on this little card. Tilt that forwards, now we can get that out. The type of bulbs we have are the wire-ended ones, so you know, it's not fun, not easy, is it? Anyway, I'll do this and we'll come back to it. So in fact I have got some wire-ended lamps. Where are these from? Probably Farnell. 410225. 410225. So a little tiny bit smaller, but it's better than using the wire-ended ones with the flexible leads, I suppose. So see if we can unsolder. Doesn't look a particularly high hour set, so there you go, but the lamps failed. Remembering to cut the excess wire off. putting the wire back on, we're just falling off. Before we slot that back in properly, let's just power the setup. Yep, that's fine. And again, yep. Right, we'll put this back together. Right folks, well that's everything done. See if it lights up now. It does. Good. Well, in that case, we'll put the speaker lid on. Hope this works. It does actually. Now I'm just going to plug the mic in that came with it, this dreadful power mic. Put this back on the test gear. Well, what I've decided what we'll do is when we do the on the air test, at the end we'll go through to this dreadful mic and show you how dreadful it is. I'll just get a battery. Okay, well I can't see it working. Let's put the picture on, show the deviation meter, and one, two, 1, 2, 1, 2, 1, 2. Whether or not it's got dirty switches or whatever, I don't know. A load of rubbish anyway. I will still go through to it at the end and see whether it says anything. Right, so all we need to do is put the knobs on. I'll just unplug that dreadful thing. So quite a lot wrong with this, but nothing serious. 10 kilohertz deviation, what a plonker. Good. Right, take it off the test gear, put it onto the aerial, which is the Antron 99, as I keep saying, that people keep asking. So it works really nicely, this, now doing 4 watts, and nice receive. So where's our standard test mic? There it is. You can spend some happy time cleaning it up. Well, it looked like we're on low power. Well, no, Roger. Right, there we go. We'll do an on the air test. So I'm sure he will enjoy that. So thanks for watching Fidelity 2001 using the Cybernet 002F board from 1981.